Funding for This Is Nashville comes from you, our listeners, and Amazon, proud sponsor of WPLN's daily show, This Is Nashville, engaging our differences so we can discover our unity. More on Amazon's community work at aboutamazon.com.
I'm Khalil Ekolona, and this is Nashville. Technology is advancing so rapidly that it's hard to keep up. Now, while a lot of people have heard about recent progress with AI, many have not heard about another scientific field that is quickly developing and could transform our world in ways we can't even fully imagine. I'm talking about quantum science. See, quantum science is the study of the smallest building blocks in energy of nature, like electrons and photons. It's a field that includes terms like superstate, entanglement, and time crystals. Whoa. Okay, I'm not talking about Star Trek or sci-fi, but it could lead to massive discoveries. Major companies like IBM and Meta, as well as governments all over the world, are racing to develop quantum computers, which are not a better version of the computers we have, but a new kind of computer altogether. A simple analogy is that the jump from current computers to quantum computers could be likened to the technological jump from a candle to a light bulb. Bam, those are going off all over your minds right now. I know it. Now, quantum computers have already been used to solve computations that would take current so-called classical computers millions of years to solve. Quantum computers are predicted to revolutionize many things from encryption systems to medical drug treatment, and it could create new types of batteries, among other things. Dr. Hanna Terlecka is the head of the new Quantum Science Initiative at MTSU. And Dr. Terlecka is a force. She's a quantum science professor and researcher who has helped secure prestigious grants from the National Science Foundation so that MTSU can train students in quantum technologies and provide them with the support they need so they can step into other jobs, higher degrees, and be in the frontier of research in this field. Starting this fall, MTSU will offer a minor in concentration in quantum science and information, and they're developing strong partnerships with other institutions like Fisk University, Tennessee Tech, TSU, Carnegie Mellon University, and Oak Ridge National Laboratory. Right now, I'd like to welcome Dr. Hanna Terlecka to This Is Nashville. Welcome, Hanna.
Thank you. Happy to be here.
Happy to have you with us. Okay, I'm asking you this big, giant question first. Why are you so excited about quantum science?
How you cannot be excited about quantum science, right? As you mentioned in your introduction, quantum is really exciting world of very tiny particles when you go to the level of atoms or even subatomic particles like electrons. And when you go to that tiny space, things behave very differently, at least to us human beings, right? And some of the principles that we use in quantum science is like superposition, like you mentioned, right? That quantum particle can be in several places at the same time. Imagine like you are in Nashville and Murfreesboro at the same time until I call you. When I call you, then you know where you are. Okay, so this is superposition. So particle behave like waves. So it's several places at the same time, as well as we can use entanglement when you can pair some quantum particle in such a way that if I decide the state I am going to be, the other particle instantly becomes the state that I want it to be. Right, wow. You can control it. So now we are in the era of quantum science and engineering technologies application. So where we are at the stage now of science and engineering and technologies, where we can apply these quantum effects, very strange quantum effects, to build novel technologies and novel materials. Like at MTSU, in our Quantum Science Initiative, we are mainly focusing on discovering quantum materials and developing new materials, understanding the behavior of quantum materials, like materials when you have many, many electrons, like 10 to the 23 particles, right? Mm-hmm. Billions of electrons interacting with each other, as well as we put some disorder in this, like imperfection, and then we observe what happens to them. How do they behave? It's like trying to predict how the crowd of big people on the street is going to behave. Are they going to make a peaceful wedding or some kind of revolution or something else, right?
Are they going to go into a similar dance number?
Exactly.
Okay, so I mean, like, what are some of the big questions that quantum science can answer with this? What the way I look at it is like the deeper and the closer you look into objects and the materials they're made of, and you are finding a way to manipulate these to come up with predictable outcomes?
Yes, so exactly. So we're trying to understand their behavior and control their behavior. For example, one of the things we are trying to do is to conduct rational design of quantum materials. Like materials, they can, for example, conduct electricity without any loss to the heat, like superconductors. And you can use these materials for energy technologies, right? This is a big challenge of the modern society, energy, right? We all want to use electricity, AC, have a warm water in our house, but that costs energy. What are alternative ways of store, generate energy? Can we build more better batteries or more efficient solar cells, right? These are quantum materials application.
Okay, so the quicker these things advance, the quicker we could do something about, addressing climate change and other
things. Yes.
Okay, so ask me this. What do you think quantum computers are going to allow us to do in the near future? Are the discoveries like those, and are they like science fiction type stuff coming closer to reality because of this?
Yes, yes, you can say so. One, I think, so there is a lot of opportunities, and also there are some hypes also in quantum computing area. But practical application of quantum computing that we are probably gonna to see soon are the like material discovery, drug discovery for medical applications, better imaging of like quantum sensors, right, that can give us opportunity to get very precise images like of brain, like to detect the early stage of cancer, for example. Or we can look at quantum sensors, right, to detect like some stuff hidden in the earth. This is relevant for military purposes as well. Or, for example, for navigating system, right? We are coming in the era where we are going to use automatic cars, right? So for navigating system without GPS. So this is for where quantum sensing application can be used. Another type of problems that quantum computing can help us to solve is optimization problem. For example, you want your goods to be delivered, and you buy stuff on Amazon, and you want it to be delivered as soon as possible with very little cost for supplies, right? So this is optimizing the path of the truck drivers, or flight optimization of the flight passes, or supply chains optimization. These are the type of problems that quantum computers are going to help us.
So this has applications in every asset of our lives. You mentioned what it could do for medical things, as far as like understanding and developing drugs. It'll help us understanding diseases and pathologies a lot better. I'm wondering, like, will it help us to improve our agricultural system and things?
Yes, absolutely. Like we can look at how to plot the crop right, how to in different areas of the world, how to utilize resources, how to send the resources in the ground, things like that.
Okay, so you are super interested in this. You were instrumental in launching MTSU's quantum science program. Where did the idea for this program originate?
Oh, it just happened to be a perfect combination of the right time and the right place.
Okay.
It started really, the biggest motivation was Quantum Science Initiative, United States Government Quantum Science Initiative, which was launched 2018, which prioritizes quantum research and quantum education and workforce development in United States due to the global competition. At the same time, in 2022, MTSU transitioned from primary undergraduate institution to research university. So now we have R2 started, so we are also focusing on training students in modern cutting-edge research. And at that time, I was able to secure several National Science Foundation grants in quantum material research and quantum information processing, like quantum computing, including the only in Tennessee expand quantum information science and engineering grant, almost $1 million, which is designed by National Science Foundation to help universities like MTSU to grow research infrastructure. And we got an excellent support, a strong support from our administration, President McPhee, Vice Provost of Research David Butler, Dean of Basic and Applied Science, College of Applied Science, Dr. Greta Van Petren, as well as our department chair. We really have a great support of the same people thinking in the same way, prioritizing quantum research.
How did you become interested in science?
I'm coming, so you can hear my accent, obviously.
Yes.
So I'm originally from Ukraine, from western part of Ukraine, and I'm coming from a humble family. My parents are workers, full-time employees at a factory plant. So I didn't have anybody in my family who do STEM. But I really like math, and I really like my middle school and high school teachers, they were so dedicated to teaching us. So that played a fundamental role in my career path. So my parents taught me that hard work and education is critical for your better life, and teachers just gave me tools to develop those skills.
What about quantum materials? How'd you get into that? I mean, if you have a love of science, there's so many paths you can take.
Sure.
You chose quantum materials. Why?
I think it started from my PhD. I was working on quantum area during my PhD. And after that, I went to do postdoctoral training in Brookhaven National Lab, University of Michigan and Simons Foundation, as well as Louisiana State University. At that time, we have been all working on quantum materials. I just love it, I never thought I would, but I did love it when I started doing things like that.
What is so special about it to you?
I think it's this idea of discovering things, of unlocking some puzzles, solving some puzzles, and solving hard problems. That kind of excites you.
I love that.
And you don't know until you try it, I think.
That's right. These are some of the hardest problems that we face, humanity faces.
It's just exciting to open these puzzles.
Okay, so you found this excitement opening these puzzles. You've gone on, captured your PhD. You started this program. If I were a student interested in studying quantum science, what courses would be offered to me? What path do you think I should take?
So starting this fall, for example, right, at MTSU, by the way, this quantum science initiative is targeted specifically for students who are interested in quantum information science, and specifically for students from background just like me, coming from first-generation college students underrepresented in STEM, women, minority students, right? Our goal at MTSU was to provide these resources for students to be trained in this, because otherwise we have several quantum science initiatives across the United States, but mostly in very top universities. And can we bring this to students just like us, just like me, in this Middle Tennessee area? So if you want to major in quantum, you will take quantum physics, of course. But now, because quantum information science, actually, that's the beauty of that. It's actually have opportunities for everyone. It's not just for physicists. It's due to the interdisciplinary nature of quantum information science, there is actually room for everyone. If you're a computer scientist, you're a mathematician, you're a chemist, you're a physicist, you can work in that field. And that's what I try to do in our quantum information science courses at MTSU, as well as Fisk University. So at Fisk University, I taught quantum computing for computer scientists. At physics, at MTSU, I taught it for physicists, chemists, engineers. And what I really like about this, people usually are getting scared about physics and quantum. It can sound intimidating. But now what I find that they're actually not scared after the class. They're really excited because we try to lower the barriers. You really don't have to be a physicist to participate in quantum information science.
You just have a sense of curiosity and a good work ethic.
Yes. Exactly.
All right. If you're just tuning in, this is Nashville, and I'm your host, Khalil Ekolona. We're talking this hour about quantum science with MTSU professor Dr. Hannah Terlecka. Okay, so I understand you all have this program down there at MTSU called the Amplify program. Will you tell me more about that?
Yes, so this is my baby. I'm very passionate about this program because this program really addresses a challenge that the United States currently have is the quantum workforce development and STEM for workforce development. According to recent studies, that one of the challenges that we have in the United States is to raise American talent, U.S.-born talent. We have many kids in the United States, but only a small fraction, like in Tennessee, less than 25% of people work in STEM. So can we bring these kids into STEM? How do we do this? There are so many opportunities, as you mentioned in the beginning. Quantum information science is going to affect practically every area of our life in multiple technologies. So there are many opportunities for work. And the Amplify program is designed to bring students, to help them to get into this workforce development, in particular to broaden participation. So Amplify program is really for everybody who is interested in STEM and quantum, and it provides research opportunities so they can be really successful and feel very good about themselves, but also faculty mentoring. Because most of our students, students that we train, it's really targeted for underrepresented group to broaden participation. And these kids, just like me, 20 years ago, I needed some help, I needed some mentoring. They're very, very talented, but my job is to provide them opportunities to be successful in research and also guide them like through the path, what internship to take, what courses to take, how to be successful. And we have been quite successful. We got 12 students in our first year.
Okay.
90% of them got into national internships, including a very prestigious and very competitive NSF REU internship, Oak Ridge National Lab Sully internships. We have several women going to graduate school, which is a great success. We have a Goldwater Scholar fellow winner, and we also have one female student, physics major. She won extremely competitive and very prestigious National Science Foundation Graduate Fellowship Research Program. And we are extremely proud of that. It works.
It works. It definitely works. Okay, so you mentioned how STEM was very important in your life and your career.
Right.
How you all are implementing that support of STEM right now to the students of MTSU. I'm thinking about anyone who's listening right now who may be a parent, who has a 6-year-old, a 10th grader, a 4th grader, and they're thinking, my kid might be interested in that.
Yes.
But sometimes kids are hesitant because they want to do things that are cool. How would you advise a parent to introduce their child, not only just into STEM, but into quantum science in a way that they would think is cool and they'll really take to it?
Thank you for this question. So at MTSU, this is the second year in a row, we are offering a summer camp for high school students. So if kids are interested, and we just ran summer camp like 3 weeks ago, and when I ask why are you in the camp, they say, my mom made me to come. So congratulations and thank you to the moms. But after that, these kids were very appreciated, for that opportunities to learn. So if you're a parent, please do send your kids to our summer camp. We have a lot of opportunities for them to try hands-on experience. They might not become a quantum scientist, but they can become interested in quantum science and benefit, from all these technologies we are developing.
I understand you have an 11-year-old son, right?
Yes.
Is he into science?
Yes, in tornadoes.
Tornadoes.
Yes.
I wonder how quantum mechanics can then predict the path or the formation of tornadoes.
Or climate change, right?
Yeah, so that'll be real important here. Question for you. Do you offer these summer camps for adults who might be interested?
Excellent question. So we do. Last week we partnered with Curica. This is a well-known company in quantum education, and we provided train the trainer. So we had a 3-day workshop on basics of quantum information. It was a lot of fun, a lot of hands-on activities. This was for high school students, high school teachers, graduate students, and postdoc and faculty. Whoever was interested, just come in and you have a really great time. And our goal is really to break the barriers. Don't be afraid of this. Once you get into this, you start to like it.
Okay. Final question for you. What is the invention or discovery that you're most interested in seeing coming to fruition through the application of quantum science?
As a material scientist, I think I'm looking forward for all quantum materials that can be discovered with quantum computing and quantum information, as well as another direction I'm looking for example, we are working now, we got this NSF grant on working how to manipulate quantum qubits, the fundamental units of quantum computers, how to make them more efficient so we can scale them up and build quantum networking so we can process information in much more efficient way. So I'm looking forward to these discoveries in these areas.
So in the future, when we have these wonderful computers, we can thank you and your efforts.
I guess so. Well, thank you.
Awesome. I want to thank you so much for being here. Dr. Hannah Teraleska is the head of the Quantum Science Initiative at MTSU. Again, Dr. Hannah, thank you so much for being with us. Keep us updated with any progress, okay?
I will. Thank you so much for having me. Really appreciate it.
Thank you. Okay, we're going to take a short break. When we come back, we are going to talk to a few students and researchers about their work in quantum science. Stay with us. This is Nashville.
Funding for This is Nashville comes from you, our listeners, and Music City Prep Clinic, Nashville-based provider for PrEP and offering comprehensive sexual health services in an environment designed to be safe, professional, and shame-free. Learn more at musiccityprep.org.
I'm Khalil Ekolona, and this is Nashville. Today, we're talking about quantum science, a medium that will probably lead to some mind-blowing breakthroughs in nearly all forms of science and computing. Now, before the break, we spoke with the head professor of the Quantum Science Initiative at MTSU. Now let's meet some of the students and researchers who are studying to break ground in quantum research. My guests are MTSU Rising Junior Ariel Nicastro and Fisk University's Adetoro Akinola. Ariel, Adetoro, thank you so much for being here.
Thank you.
Thank you for having us.
This is really great. Okay, so you're both rising juniors, taking a lot of the introductory courses that are probably heading into more specialized courses this fall, I imagine. Can you tell us what are your majors, Adetoro?
I'm a computer science major.
Computer science major, Ariel.
And I'm a physics major.
Physics major. All right, so did you know, Ariel, that you wanted to study science when you got to college?
I knew that I wanted to study science. However, it was a very last-minute decision to study physics, actually.
How'd you come to that?
So for most of my grade school career, I always thought I wanted to do chemistry. And I thought, oh, maybe chemical engineering, something with a lab coat. Very cool, because I was younger at the time and thought that was so cool. But I took a physics class in my senior year of high school. And then I decided, I didn't decide to do physics at that time. I said, let's do mechanical engineering. Mm-hmm. So I applied to most of my schools in an engineering field. However, what made me go with physics at MTSU was that I got a great fellowship with the MTSU Honors College, and I didn't want to turn it down. So I looked at computer science and the physics departments, and the physics department just spoke to me. The faculty was fantastic. I felt like I would have so many great opportunities in the supportive environment here. So I thought it was a no-brainer decision to choose physics.
Do you still get to wear a lab coat?
I actually have not worn a lab coat yet, so I'm waiting for it.
Okay, we're gonna have to get you one. We're gonna have to get you one. Adetoro, what led you? Did you know that you wanted to study science, particularly computer science?
Not computer science, but science since I was little, yeah. My initial goal was to study medicine, because all the books I read when I was younger were anatomy books, Ben Carson books a lot when I was little. Mm-hmm. And around the third grade, I remember my parents started giving me their phones to play games. And I just was really interested in why I could play games on this little brick. And since then, I've been interested in computer science.
Okay, now I understand you both have taken quantum science courses that were taught by Dr. Teraleska, who was just on the show. What was it like for you in those courses? Adetoro.
It was an interesting experience because I went into that class having zero idea about anything quantum related. I'd taken like elementary physics and that was it. But I remember the first class, Dr. Hannah was so happy and passionate about everything. And she was telling us like some intro quantum physics stuff. And she mentioned that the early pioneers of the field, like Schrödinger, when he proposed things, he actually thought that quantum science was absurd. Because it seems absurd when you think about it. And Einstein as well also thought it was absurd. So I went to, after the first class, I already thought that this class was absurd. But like, yes, if it's absurd and we can make it work, that would be an exceptional thing to do.
Okay, that's pretty cool. Ariel, what was it like for you in those courses?
So I first got into these courses not knowing anything, like Adetoro. However, I eventually was able to get a grasp of the math behind quantum and how you can apply quantum, and just learning about everything step by step really made me feel more empowered in the field of science, because quantum is typically something that people think is far off, that you can't really easily get into. But having this beginner level course made me feel, wow, this is fantastic and I'm learning a lot. So my goal in there was to learn, and I did that.
You know, a lot of people hear terms like quantum science, even physics or computer science, and they're like, wow, this is so hard, so many numbers, so many formulas. I don't know if I can even understand what it is, let alone follow it as a course of study. There's a lot of potential intimidation that comes with taking on such a monumental course of study. But Adetoro, you mentioned that Dr. Hannah was so passionate that it kind of made you feel relaxed. How important is it for you? You both are students. You've been taking courses for a while through elementary school, middle school, high school, and now in college, and soon to be postgraduate degrees. How important is it to have professors who are passionate about the topic that they're instructing you on?
I think it's super important for me, at least, not just professors, like anyone around in your life, in the books you read. Like, as I said, my initial intro to STEM was through reading books. I could feel the passion in the author's words, and that's what got me into STEM. And also quantum computing. In the class, I really didn't have, I didn't really expect to do really well in the class because I expected it to be a very high level class. When Dr. Hannah's passion just made me dive into the class. Outside the class, I would do my own research. I did a fellowship with IBM to learn more about it because of Dr. Hannah's passion. So for me, that's really important because it resonates with the students and can drive them to do more and pursue more in the field.
Now, Ariel, your friends, are all your friends into science, or?
I actually have a lot of friends that are all over the place. So, yes.
So when you talk to them about what you study, what you're discovering, what you're learning, what are their reactions? How are your peers reacting to this field that you're pursuing?
Well, they all say that it's incredibly cool and that they often do not relate, but they really support my endeavors and my interests, and I do the same for them. So I think it's a really great thing to have friends outside your subject as well as within your subject.
Do you relish an opportunity to really explain something? You understand this great theory or this new breakthrough that could be on the way. Do you really enjoy like breaking it down to friends and family? Like, hey, this is how things are and this is what the future holds?
Yes, actually, I met someone a couple days ago, and this was at my summer internship. We were having a summer symposium presenting our posters, and someone was doing a peer review on a quantum computing project. And they said, "Do you know anything about quantum computing?" And I said, "Actually, yes, I do." And so she just asked me to explain a very basic rundown of it. And thanks to Dr. Terlecka's class and the experiences I had at MTSU, I was able to help her understand it and do her reviewing of the posters better. And I just thought it was really great to be able to pass on that knowledge.
That's awesome. Now, if you're just tuning in, this is Nashville, and I'm your host, Khalil Ekolona. We're talking this hour about quantum science and its future. My guests are students Ariel Nicastro and Adetoro Akinola. All right, so when it comes to quantum science, Ariel, answer this first for me. What are you most curious about?
Well, that is a great question. I mean, for me, I'm really interested from the technological perspective and the material science perspective. So I'm honestly really curious about how quantum can improve the technologies we work with every day.
Okay, go a little bit deeper for me. Like what type of technologies are in your mind when you're exploring this curiosity?
One thing that really fascinated me this past year or so was actually what Dr. Terlecka mentioned last session was optimization. So for example, making things more fuel efficient by finding better routes and basically things that make the environment cleaner, I suppose, or just being able to help the world we live in. Okay,
I like that. Adetoro, what are you most curious about in quantum science, or are you curious about quantum computing as well?
I guess for me it's more quantum computing since I'm more of a computer science major. And for me, I'm curious about the sheer computational power we can have access to with quantum computers, particularly for decryption and stuff, because that's one major application everyone talks about for quantum computers, being able to crack all our current encryption patterns. So yeah, that's
okay. So quantum computers are going to be able to crack any encryption. So whatever I'm sending encrypted on WhatsApp or what have you will soon be visible to anybody who has that program.
Okay, I won't say any, but some of the common ones, yes.
Okay. All right. So I want to talk a little bit about persistence. There's a lot to learn. Both of you are probably studying. How many course hours are you taking per semester?
Let's see. I started out in my freshman year with 18, but luckily I've been able to gradually go down. So I think now I'm about at 15.
Okay.
Still hefty.
That's a lot, but it's reasonable. Okay. Adetoro, what about you?
I think at this point I average 17 a semester.
That is, okay, so that's a lot of work. You're in college. Do you all still find time to have the social experience of college and being there and enjoying yourselves as this young time in your lives?
So I find that there's a great community within the physics department. So while you might be studying or doing your work, there's a room at MTSU in the physics building where people can come together and hang out a little bit while they study. However, most of my socialization has been done with organizations that I'm involved in or people that I've met. Occasionally, I'll go to a couple on-campus events.
Yeah.
And it does definitely get difficult when you have a lot of midterms and finals to balance out.
And so I'm curious, like, what's the hardest part about your academic journey?
I think I had a course last year, theoretical physics, and that basically taught you all of the math you need to know for upper division physics, which I'll be entering starting in this fall. And I think that the amount of effort and time dedication that you had to put into it made me realize that you have to always be on your A game and always put effort into it and never procrastinate. So I did have to learn how to balance everything that I wanted to do. So I still work towards having a healthy lifestyle because that's something you can't really go without. And I think that just being able to balance that, but also have the persistence to work towards your studies was a very important thing I learned.
And having a good support group is instrumental in all of those things.
100%.
Okay, Adetoro, what's the most difficult part about your academic journey? Is it like all the code you have to learn?
For me, the most difficult part would be, I would say, navigating computer science as a whole, because computer science is a very, very, very broad field. So, and there are so many things that you find out about that you would really want to get interested in, but at the end of the day, you can't do it all.
Yeah.
So trying to find one thing or a few things that you would see yourself doing a long time.
You just mentioned that you guys just got back from IBM for an internship this summer?
I did a fellowship with IBM. I was at Meta for internship this summer.
Okay, so tell me about both. Tell me about the internship in Meta and then your fellowship with IBM.
So my internship at Meta was a software engineering internship. I was on the infra team for business messaging at Meta, particularly marketing messaging. So yeah, I was practically working on the load testing for the campaign creation and the delivery engine for how messages actually got delivered to people.
Okay, you're out there in California doing that. All right, so what's your fellowship with IBM? What's that about?
It's called the IBM Accelerator Program. So it's for college students who are interested in IBM and want to learn more about the company. So yeah, you do some professional development sessions every Monday, and on Wednesday you do some track-specific sessions. And there are different tracks, and my track was a research track. So everything we did was more research, IBM research inclined.
Do you enjoy the research?
Yeah, I really enjoyed the research.
Okay, now Ariel, what type of research opportunities have you been exploring?
Actually, I've been exploring many different kinds. It's very funny. My first ever project in my freshman year was in acoustics. I had an NSFRU at the University of Maryland in summer of 2023 in biophysics, which had a bit of engineering design involved. And then this past year, I was working with Dr. Terlecka in a more computational project involving quantum materials. And this past summer, I was at Oak Ridge National Laboratory working mostly in material science, however, a little bit of coding as well.
Okay, we're going to talk to a scientist from Oak Ridge. What was it like being there at Oak Ridge?
It was fantastic. Honestly, if I'm being completely honest, a huge bucket list item. And I learned so much because everyone there has so much to tell you, and you can learn so much from the people that you interact with every single day. Because it's essentially, I think when I was there over the summer, there were 7,000 people at Oak Ridge's campus.
Wow.
Including interns. And everywhere you go, you meet someone new and you can learn about their projects and what their interests are. I actually learned about several fellowships and types of research that I never heard about before. So
you've been to some conferences as an undergraduate as well, right?
Yes.
What's that environment like?
Well, I had to learn how to navigate a conference environment. My first conference was with Women in Physics in 2023, in January, I believe. And I went to every single session this one day. And by 4 p.m., I was burnt out and was done. But there were 2 more days left in the conference. So, of course, that's a bad thing to do. And so I realized over time that a conference is all about learning what you want to learn and connecting with others. And I enjoy exploring the campus and learning more about these places because sometimes it could be where you might end up going to graduate school, for example, or you might be able to connect to this university.
All right. So the final question for you both. I mean, I do want to know, like, what's the big discovery that you're thinking in the back of your mind that you'd love to, come up with and find throughout the course of your study? But, you're both scientists right now, and you're scientists of the future. What's the legacy that you want to believe behind, not just for the world of science, but for the world in general? What is it that you want to be a part of doing? Adetoro.
That's a loaded question.
Yes, it is.
For me, I would say quantum related. For me, I would say trying to create more efficient algorithms or hardware for quantum error correction to make quantum computers reach their full potential.
Okay. I like that. Ariel.
For me, I think the legacy I want to leave behind, or just message to give to others, is a bit more like interpersonal. I guess you don't need to know anything about a subject to jump right into it. You can try many different things before picking what you're interested in. Of course, I had many different research projects and I'm still learning about what I like. But I think that being able to have the confidence to jump into something that you're unfamiliar with is something so important. And being able to grab those resources is also a very great thing.
Having courage.
That's a big one, yeah.
Yes. I want to thank you both so much for being here. Good luck to you in your studies this junior year. Trust me, time goes by quickly, so I'm sure we'll be having you on some version of the show to talk about the discoveries that you both have found. Ariel Nicastro, is a rising junior at MTSU, and Adetoro Akinola is a rising junior at Fisk University. Scientists of the future, y'all. Remember their names. Thank you again so much for being here.
Thank you for having us.
Awesome. We're going to take one last break. When we come back, we'll take a look at the jobs in quantum computing and quantum science, and we'll learn what it's like to work in the quantum industry. You can also join the conversation, as always, by tweeting us at This Is Nashville. We'll be right back. I'm Khalil Colonna, and this is Nashville. All right, today we are breaking it down to the very smallest particle. Yes, we're getting quantum. We're exploring the world of quantum science. We've spoken to a professor who is heading up the program at MTSU. We just spoke with students who are working hard to be the next generation of quantum scientists. Now let's learn what it's like to work in the quantum field through quantum computing. Joining us now is Dr. Stephen Jess. He is a distinguished research scientist at Oak Ridge National Laboratory outside of Knoxville. Dr. Jess is the section head for nanomaterials characterization at Oak Ridge. Stephen, thank you for being here. Welcome to This Is Nashville.
Thanks so much. It's a real honor to be here.
Really appreciate you being here. Okay, so for those who don't know about it, what is Oak Ridge National Laboratory? What happens there?
Right. So it's probably shrouded in mystery for some folks. I think it was for me too, and I didn't know what was going on there. But really, it's the largest open science national lab in the United States, and has probably one of the most diverse portfolio of science projects that are being worked on. So it's a large institution, and really the mission of all the national labs together is to really, address the nation's needs in terms of discovery of new technologies and the fundamentals of science.
So I was living out in New Mexico, as listeners may know. I'm familiar with Los Alamos National Labs out there, and going to that town is really pretty, but it kind of reminded me of Stranger Things. Does Oak Ridge give the same feel?
Well, I'm told that the writers actually based some of their story on that. And so, I feel like I'm the target market for that.
Okay.
Because I'm at Oak Ridge. I also went to Hawkins Middle School up in Hendersonville, which is, the same name as the show. So, yeah.
So we're not going to go to the under.
No. Yeah.
All right.
Be careful where you go with that.
We'll stay away. All right. So I want to talk a little bit about your current research. What are you currently looking to answer?
Right. So, I'm a microscopist. That's my main job. And really, we have some of the most advanced microscopes anywhere at Oak Ridge. And they allow us to look at the atomic scale and actually operate at the atomic scale. So we can see atoms one at a time. And we're developing methods to use those microscopes, not just image what's happening at the scale, but actually build things, move atoms around, and ideally make something that will be relevant for quantum computation.
How do you move an atom around?
Right. So there's two primary ways. The first one and more traditional one is using these microscopes called scanning probe microscopes. And the thing to think about there is they're kind of like a record player in that you've got a really sharp needle that goes across a surface. I don't know how many people remember what a record player is, but
I did.
But this needle is sharpened down to have just a single atom at the end. So that's the only interaction with the surface, and so you can trace out a surface that way. Wow. And since it's a solid thing that's touching the surface, you can actually pick up atoms, move them, and put them where you want. The second method, and the one that I'm more working on, is using electron microscopes. And those focus an electron beam to less than an angstrom, which is less than the distance between atoms. And we can, basically look at an atom, shoot it, knock it out, and put a different one in its place.
What is it like to observe an atom in action?
Yeah, no, it's mind-boggling. First of all, it's the scale because, you're zooming in the whole time, and it's orders of magnitude to go from where we are here down to that scale. It's a billion times smaller. And it just makes it real. I mean, it wasn't that long ago that people didn't believe that atoms existed. Some of the top scientists didn't believe that atoms existed, but we see them and we're interacting with them.
All right, so quantum computers. Break it down for us. How does it work?
Well, I guess the main thing to take away, and this will sound weird, and if it sounds weird, then you're probably correct because it is really weird.
Okay.
But I think it's good to compare it to a regular computer. So digital computing, it's binary. There's a 1, there's a 0, and nothing in between. A qubit, however, which is the fundamental unit of quantum computing, can be in 2 states at once. It can be a 1 and a 0. And that's really kind of par for the course for everything in quantum. It's this smeary kind of undecided world, and that's what it looks like to us. So this qubit can be in 2 states at once until you ask it, what state are you in? And because of that, you can do calculations in a very efficient way that you can't do any other way. So a good way to think about it is, the Robert Frost poem where you're in a yellow wood and you're at a fork in the road and you got to decide which one.
Yeah.
And he takes the one least traveled and laments that he couldn't take both. But a qubit could actually take both. And so if you're looking for the best solution, you can, with a normal computer, you have to walk down one, come back, walk down the other, come back. With quantum, you can go down both.
You understand it all at the same time.
Yep. It's highly parallelized.
Now, I understand that the temperature required to run quantum computers is 460 degrees below zero. That's literally as cold as space is. Why do quantum computers need space cold to operate?
Yeah. And that's because quantum fluctuations, or the quantum phenomena that we're interested in, are very sensitive to their environment, at least for the kind of qubits that are being built right now. And I think a good metaphor for that is to think about a football stadium during kind of a lull in the game. It's a blowout. People are kind of bored, so they do the wave. And so you get this large spontaneous formation of people agreeing all together that they're going to do the wave. Electrons can do that. Other little particles in matter can do that. And that becomes something big that we can get our hands on. Now, at higher temperatures, that's more like the home team scores their touchdown last minute, wins the championship, everyone goes crazy. You're not going to get a wave going then, right?
Okay.
And so you need that cold to calm everything down, get those thermal fluctuations away, and then you can allow natural quantum phenomena, which is there all the time, but let it emerge and be dominant.
Wow, that's really cool. Tell me this, what potential breakthroughs in quantum science or quantum computing are you most excited about?
Yeah, I mean, like the other guests, it's having that capability to answer these much harder questions and model and run these what-if machines. What is the universe going to be like if we do this? What's the weather going to be like if we do that? If we put this medicine in a person, what's going to happen? The kind of computers we have right now can't answer those questions, or it would take so long, it'd be longer than the age of the universe to find the answer. But a quantum computer, if it's efficient enough and big enough, and runs well enough, it should be able to answer these questions much more quickly. And I guess the other part, which is more in line with what I'm interested in, is that quantum sensing, which is probably the first, real world applications that we'll get with quantum. It's more accessible. Because I'm a microscopist, I'm interested in finding those little signals in the world. Quantum sensors can be way more efficient at doing that than what we have right now.
Okay, so the quantum sensors applied in the real world, how are we going to see that appear in our lives? Will it be a quantum sensor, say, on some weather station to detect hey, we've got a gnarly storm system that's going to be coming in 3 weeks or what have you. Like, explain to me how we can see this applied in our daily lives.
Right. There's quite a vast array of what you can imagine. Certainly, detection of weather, detection of events. There's a lot of hope that some of these sensors can detect dark matter, or at least refine the search for that. So the big physics questions about the universe and how it works, we hope to be able to answer with quantum sensors. We actually recently installed a microscope at one of our labs that is based on a quantum sensor, and it allows us to map out magnetic fields at a really small scale with extreme sensitivity. Anything, accelerometers that are in your phone that help you figure out direction, all those kinds of things will be improved.
So if we go 50 years in the future, will we have like little holographic boxes following us around acting as our phones?
I don't know if that's going to happen, but I mean, we expect to be able to solve problems more easily and just be able to detect things with more confidence.
Yeah, I said this at the top of the show. A lot more people are familiar with AI than quantum computers and quantum mechanics. Is there a symbiotic relationship happening between artificial intelligence and quantum science and quantum computing?
No, I think so. And they go hand in hand. One helps the other. So right now, because we're still working on discovering materials for quantum materials and understanding how it works, we can use AI to help refine the search for those materials. And then if you think about what it takes to actually train a neural network, that's a huge optimization problem. And that might be exactly the kind of thing that a quantum computer can accelerate tremendously. Because if you think about, ChatGPT, to train one engine, it's like 9 months and the power for a small city to do it.
Yeah.
It'd be much better if we could do that more efficiently.
Okay, so I want to talk about Oak Ridge a little bit. We just had a student who spent some time, Ariel, she spent time at Oak Ridge. What are the programs that Oak Ridge offers students who are early career scientists?
Yeah, it's vast. And I'll say that, I was one of those students. I was an undergrad at UT and did some projects out at the lab. And even in grad school, half my thesis was on the work that I did at Oak Ridge, and I was a postdoc there as well. I ran the gamut there, and there's a lot out there. There's lots of fellowships. We can even maybe provide some links on your website after the show.
That'd be great, yeah.
Oak Ridge is definitely devoted to reaching out and bringing in the next generation. Your science is only as good as the next generation that you teach to carry that baton, and we recognize that. So at all levels, we can bring people in. Tours is really good for the K through 12 folks. I love it when the high school students come in. They're way more engaged. They ask way more interesting questions than sometimes the honorable people that we get coming through. So they're great.
Okay, so outside of technical skills, what kind of soft skills do researchers interested in working in quantum science, what do they need to have?
Yeah, and I've heard some mention of this with some of the other guests, but that tenacity, really willing to push through the problems. You need to have that pioneering spirit, right? Because the roads haven't been built to where we're going yet. And so you got to pull out the machete and cut through the vines and get through there. And you'll get the snake bites, you'll come across a canyon that you can't get across. And so you need to be able to figure out how to get around it and adapt. And then part of the other thing with that is that when you get to those boundaries you can't cross, you need to be part of a team that can help you, get through those problems. And so you need to be a great team member. So, check the ego at the door. Yeah, you have an idea about how it, what the solution is, but maybe there's some better ones out there. So being able to do that back and forth in a constructive way is critical to doing research. It's critical for most jobs, but I think in research where there's so many unknowns, it's really an important aspect to have.
Now, so you have to be kind of willing to be wrong a little bit. You have to be willing to be wrong, but also the willingness to adapt and to change, to be ready for things. Because at one point in time, they thought the Earth was flat, or that the sun revolved around the Earth. But now we know with all the discoveries that it's something else that had bravery. I got time for one final question for you, and I don't know if you got a security clearance. I don't want to blow that. But what do you want the public to know about the quantum research that's happening right here in Middle Tennessee and how it can improve our lives?
Yeah, I mean, I guess it's important to know that Tennessee is active in this area. I think we're sort of at an inflection point where, maybe the silicon industry was 50 years ago, where we know that some of these things work at the lab level, and now we need to get it out in the world. And Tennessee is equipped with the personnel, the capabilities, the education system to be on the forefront of that. And I'm excited to see what we can do around here.
Okay, and just use our imaginations real quick. What's something that you want to see quantum computing develop?
On a consumer level.
Okay.
That's a good question. I think secure communication is a really important one, and that's not necessarily consumer, but it's national security kind of thing. But I also believe that, doing medicine and understanding how drugs work in people, that should be able to be modeled, and I think we're ready to do that.
I think we're going to get close to it with the help of folks and brilliant minds like yours. Again, thank you so much for being here. Dr. Stephen Jess. Is it Jesse or Jess?
Jesse.
Okay, I'm sorry about that.
Right.
Dr. Stephen Jesse is the section head for nanomaterials characterization at Oak Ridge National Laboratory. Again, Doctor, thanks for being here, and thanks for the work you're doing.
Yeah, thanks so much.
Thank you to you for tuning in this hour. This is Nashville as a production of Nashville Public Radio. Today's episode was produced by Katherine Ceicys. It was directed by Tasha A.F. Lemley. Our technical director and board operators, Liv Lombardi. The masterminds behind our theme music are Larange and Namir Blade. You can listen back at thisisnashville.org or wherever you get good podcasts. And our conversation never ends here. You can tweet us at This Is Nashville. Find us on Instagram. Tell us what you want from our show by filling out our quick survey online. You can also call to leave us a message. 615-751-2500. This is Nashville. I'm Khalil Ekalona. We'll see you tomorrow, everybody, and be good to each other.